Catch drains on steep grades were constructed in concrete to prevent scouring. Some median drains were also constructed in concrete. The concrete in both catch drains and median drains was coloured dark grey to blend into the natural surroundings. Excavations were made for longitudinal culverts. The culverts consisted of precast concrete pipes, bedded on sand and carefully aligned and graded. Concrete curbs and gutters through cuttings were initially constructed by pouring concrete into stationary forms. Later, the more economical and modern method of extruding concrete from a machine was used. Subsoil drains consisted of earthenware pipes laid with pervious joints in trenches. They were backfilled with specially graded filter material. At the works depot, concrete drainage units were precast. At the site, they were placed on fill batters to carry surface water clear of the road formation without causing scour. Meanwhile, work was proceeding on major structures. For Mooney Interchange Bridge, pre-stressed concrete girders were lifted into position on the headstocks. The ends of the girders were seated on neoprene pads set in cement mortar on top of the headstocks. Due to the widening of the expressway near the toll barriers, Mooney Interchange Bridge tapers in width from 205 feet to 221 feet. On Giles Bridge, headstocks were completed, ready to receive the girders which were manufactured some distance from the site. On South Mount White Overbridge, units 45 and 50 feet long were lifted into position whilst traffic continued to flow on the highway beneath. Work continued on Mount White Interchange Bridge, which features a box girder cast in situ type of construction. By mid-1965, from Hawkesbury River to Mount White, the expressway was taking shape. difficulty in establishing an expressway through this rugged terrain is here evident. At this stage, construction commenced on Section 3 between Mount White and Calga, a length of 3.5 miles. This section included 2 interchanges, one where the ultimate route will turn towards Gosford, and the second at Calga, where traffic continuing to Newcastle and the north separates from traffic proceeding direct to Gosford. 4 relocations of the existing highway, totaling 2 miles, were necessary on Section 3. On this section, 2 million cubic yards of rock was excavated and moved from cut to fill in a period of less than 12 months. Daily output increased as more advanced equipment became available and greater experience was obtained. At one time, these sandstone ridges were used by Aborigines for ceremonial purposes, and their rock engravings were frequently encountered during construction. The engravings were carefully recorded before blasting. In some cases, engravings were cut out and removed for preservation and public exhibition. Section 3 includes 3 bridges. 1, the Stub Bridge, crosses the ultimate expressway route where it turns towards Gosford. This is a post-tension concrete box girder structure. The single pier is V-shaped. Tubular steel falsework was erected to support the superstructure during concreting. The next bridge carried the existing highway over the expressway between Mount White and Calga. It is a post-tension concrete structure with a long central span across both carriageways. Piers and abutments were constructed of reinforced concrete cast in situ. Precast concrete sections were brought to the site, assembled on the ground, and post-tension to form girders. The third bridge was at Calga, where the expressway crosses the interchange ramps. It has 3 spans of steel girders. The pier columns consisted of reinforced concrete inside concrete pipes, which took the place of formwork. Pavement construction was now proceeding on sections 1 and 2. The sub-base of selected sandstone, 12 inches thick, was trimmed to the required crossfalls. The base course layer of crushed basalt was placed in 2 4-inch layers, giving an 8-inch thickness. After accurately trimming the base course, a bituminous surface dressing was applied, using 3/16 of an inch aggregate. The intermediate course of 3/4 of an inch asphaltic concrete was spread 2 1/4 inches thick. Asphalt curbs were provided along edges of the formation. The 10-foot wide shoulders, or breakdown lanes, were surfaced with a spray bituminous seal, using a 3/4 inch cover aggregate to give a coarse textured surface, contrasting in appearance and tire noise with the travelling lanes. They were surfaced with 3/8 of an inch asphaltic concrete, laid 3/4 of an inch thick. A A mechanical spreader was used for laying the 8-inch thick base course, which was composed of graded crushed basalt from local quarries. After being watered, the base course was compacted by vibrating rollers. Surface levels were checked. Final surface trimming was carried out by grader with further compaction by pneumatic tired rollers. The largest, of 32 tons, provided for varying the tyre pressures whilst in motion. A 10-foot straight edge was used to locate variations in the surface. A bituminous dressing was used to protect the surface until the next course could be applied. To the application of the intermediate course asphalt, a bitumen emulsion tack coat was sprayed on the surface. Asphaltic concrete 2 3/4 inches thick was spread and tamped by a mechanical paver. The initial compaction was by a steel roller and secondary compaction by pneumatic tired roller. Tracks were laid to take an extrusion machine, which was used to place an asphaltic concrete curb on the outer edge of the intermediate course. A manually operated unit was also used for this work. In the meantime, holes were bored along the edges of all fills to provide for guardrail fencing posts. Application of the final pavement course was delayed until this and other work on the adjacent roadside was completed. The guardrails were secured. The roadside was landscaped to restore it as closely as possible to its original appearance. This work involved spreading of topsoil on fill batters and disturbed areas. Grass seed was planted. Fertilizer spread. And the area watered. The ground surface was sealed with bitumen emulsion to prevent scour and assist germination. The grass was quickly established. Grass sods protected earth drains, whilst the steeper slopes were planted with indigenous ground covers. Native trees and shrubs were planted in carefully selected locations to enhance the roadside appearance and reduce headlight glare. boundaries were fenced throughout to exclude people and stock, as this road was constructed for vehicles only. Using the extrusion process, concrete mountable curbing was installed at ramps where narrow medians were necessary. Outer edges of the travelling lanes were masked for protection before spraying bitumen on the shoulders. Aggregate was applied directly to the bitumen to give a cover of 1 stone thickness, and then rolled by pneumatic-tired multi-wheeled roller. After rolling, any excess stones were removed by compressed air and brooming. Travelling lanes were then surfaced with asphaltic concrete. A profileometer checked the surface to ensure that the final pavement was finished to within very fine tolerances. With the completion of the surface course pavement and the provision of signs, lights and other traffic facilities, the first 2 sections between Hawkesbury River and Mount White were brought to completion. These sections were opened to traffic in December 1965, using an interchange at Mount White to connect with the existing highway until the next section of expressway was completed. Earthworks then proceeded at an accelerated rate on section 3. At Mount White, work was continuing on the stub bridge. After formwork for the girders had been erected, cable ducts were placed on the structure. Pre-stressing cables were prepared for insertion into the ducts. The ducts were then lowered into final position. Concrete was conveyed from transit mixer onto the structure by a monorail system. And placed into the girder formwork. After concreting, the high tensile steel cables were tensioned. The stub bridge was completed. Meanwhile, at the highway overpass bridge between Mount White and Calga, the girders had been assembled and stressed. They were then moved by jinker from the assembly area to beneath the bridge and lifted into their final position in the structure. Reinforcing steel was then placed in position for the deck. Transit mixers delivered the deck concrete. At the Calga interchange bridge, steel girders were in position. Concrete was placed to form the deck, and workmen applied the finishing touches. The third section of the expressway was then nearing completion. All signs were manufactured at the Department of Main Roads Central Workshop at Granville, near Sydney. Easily read signs with large lettering were needed for the high-speed traffic. Where signs were required above travelling lanes, steel trusses were constructed to support them. The signs were of different colours and reflectorised. At interchanges where overhead lighting was to be provided, signs were illuminated by fluorescent tubes. Reflectorized delineators were placed at the outer edges of the road formation, using a red colour to indicate the left side and white for the right side of the carriageway. A blue colour was used on interchange ramps. Toll collecting facilities were provided at Mooney Interchange using prefabricated cabin units. Cables for emergency telephones were laid in trenches along the edge of the formation. They were protected by a layer of concrete. Telephones were erected at 3/4-mile intervals and connected to the administrative centre, from where an emergency patrol wagon operates in the event of breakdown or accident. Lamp standards were erected at all interchanges and toll barriers, which were illuminated with sodium vapour lamps to provide safe conditions for traffic entering or leaving the expressway at night. Were spray painted on the road surface to define travelling lanes. This was the final construction activity on the project. In 1966, 3.5 years after its commencement, the first 10 miles of rural expressway in New South Wales was brought to completion. But this is not the end of the story. The fourth stage of construction is already proceeding on the southern side of the Hawkesbury River Valley towards Sydney. In the meantime, motorists using this road are now able to enjoy the comfort and convenience of fast travel under safe driving conditions. The Department of Main Roads takes pride in the achievement of surmounting the great difficulties associated with the construction of an expressway of world standard through such rugged terrain, and plans to construct other similar expressways throughout New South Wales for the benefit of the travelling public and, indeed, the whole community.